In our last session, we discussed the design of controlling the forward and reverse rotation of a motor using an S7-1200 PLC, but the specifics of implementation are the focus of today's lesson. Firstly, following the PLC's I or O hardware wiring diagram, we install the wiring and connect to the computer via an Ethernet interface using a network cable. Let's now examine the wiring for the forward and reverse rotation of the motor. We have a 220 volts power supply that outputs two 24 volts positive power sources. We start by connecting the positive power supply to the PLC's L+ terminal and the negative to the PLC's N terminal. Then, we connect the positive and negative power supplies to the PLCs for L+ and 4 N terminals to serve as the load power supply. One end of the thermal relay's contact is connected to one end of a button. The button is connected to another button, which is further connected to an additional button. The common terminals of these three buttons are connected to the L+ terminal of the PLC. The first button, for forward start, is connected to the I0.0 input terminal of the PLC. The reverse start to the I0.1 input terminal. The stop button to the I0.2 input terminal. And the thermal relay's contact to the I0.3 input terminal. The common terminal 1N of the PLC's input is then connected to the N terminal of the power supply to complete the input signal circuit. The PLC's output terminal Q0.0 is connected to the 13th terminal of the contactor KA1, and the PLC's Q0.1 output terminal is connected to the 13th terminal of KA2. From the 14th terminal of KA1's coil, it connects to the normally closed contact of KA2, and from the 14th terminal of KA2's coil, it connects to the normally closed contact of KA1. The normally closed contacts of KA1 and KA2 are linked together and return to the negative power supply 4N. Since the controlled DC devices KA1 and KA2 cannot directly control the motor, we use the open contacts of KA1 and KA2 to control the coils of the AC contactors KA1 and KA2. The 380V power supply comes to our two linked contacts. From the open contact of KA1, it connects to one end of KA1's coil, and from the open contact of KA2, it connects to one end of KA2's coil. The other ends of KA1 and KA2 return to the power supply. Open the TIA Portal software and create a new project titled Motor Forward and Reverse Control. Here, you can select the location to store this project. We are currently placing it on the desktop. Click OK. And then click Create. After creating the project, we open the project view, and then in the project tree, select Add New Device. The device name can be set or left as default, typically PLC1. We select the controller, choose S7-1200. Select its CPU. Choose the 1215 DC CPU, and then select its version, with the bracketed version being 4.1. Click OK. A PLC is now displayed, and we can add it to our project. Caution: after adding this PLC, its model, order number, and version number must match exactly with the actual PLC used. Any inconsistency will prevent the established control project from being downloaded to the PLC. After adding the PLC device, a device view window appears. Select the PLC, click on its properties. General. Here, you can retract properties. In this section, we can find the Ethernet address, and this IP address must be set correctly. The first 3 digits 192.1680 must correspond to the IP address inside the computer, and the last digit can be set arbitrarily. If the first 3 digits do not correspond to the computer's IP address, the project also cannot be downloaded. For PLC programming, click on Program block in the project tree, and then open the main program OB1 by double-clicking. Which brings up our program editing box. We input the originally designed program. Click here with the mouse, input /. Stop overload. Interlock coil, and then move the mouse here. Click the right arrow, and then input open contacts, self-locking contacts, and point upwards. Here, the corresponding contacts input their addresses. I0.0, I0.2, I0.3, Q0.0, Q0.1, Q0.0. Appearing above is I0.0 corresponding, below is variable 1. 1 is the absolute address, and the other is the variable name. We can modify the absolute address here, display method, and symbol display method. We can use copy and paste to copy the /start/stop program. Then paste it into program segment 2. And then modify the input. Change I0.0 to I0.1. The stop button I0.2 does not need to be changed. Overload I0.3 does not need to be changed. The reverse output uses Q0.1. Self-locking contact Q0.1. Interlock contact this Q0.1 is changed to Q0.0. Then the reverse control program is also designed. And then we click here to compile, to see if there are any errors in the program we designed. Below, it displays successful compilation, no errors, and then we need to download the program to the PLC. Connect the PLC power, and then click on this project, PLC download. In the extended download device box, there is a choice of interface here. We choose the Ethernet interface, and then select this network card, and then start to search. Search for our corresponding PS, and click download. After downloading, we need to download the program to the PLC again. We need to stop the PLC, so here choose to stop loading completely. After loading, it displays Start Module, which is to let the PLC run. After completing, we start to debug the program, operate the corresponding control buttons. We can see the working process of the electric motor after the PLC runs the program. This is a program written with general instructions. We can delete the entire program and then use the second method to write the program. Use the set instruction to write our electric motor forward and reverse control program start. Use open. There is no reset instruction here. We can choose the bit logic operation instruction in the right instruction box. Choose the reset instruction, and then click and then choose the set instruction. This is the forward start I0.0. This is reset Q0.1. Set Q0.0, which resets the reverse to 0 to stop, and then lets the forward Q0.0 set. To start forward, this is the forward start. Similarly, I0.1, reset the forward Q0.0. Start the reverse Q0.1. This is a forward start process, and 1 is a reverse start process. And then stop and overload. Stop. We use reset. Add an overload here. Stop is I0.2. Overload is I0.3. Q0.0. Q0.1. This section of the program mainly is when stop and overload, reset the forward or reverse at the same time, stop. After writing the program, we can download it to the PLC again. Click download. It asks if we want to overwrite the original program. Choose yes. After downloading, we can directly operate the PLC. Then, it runs according to the new control program. Debugging the program, now we press the electric motor forward start button, the electric motor runs forward. We press the stop button, the electric motor stops. We press the electric motor reverse start button again, the electric motor runs in reverse. Press the stop button again, the electric motor stops. Now we press the forward start button again, the electric motor runs forward. During the operation, if the electric motor overloads, we now simulate the overload phenomenon, the electric motor will stop. This concludes today's lesson.